Have you ever wondered how Pluto, the dwarf planet, was formed? Let's journey way back to around 4.6 billion years ago. Picture a young sun, enveloped by a swirling protoplanetary disk of gas and dust. This was a time of cosmic infancy, a universe in the throes of creation. Within this chaotic disk, a certain region began to collapse under its own gravity. This gravitational collapse set the stage for an extraordinary event. It led to the formation of the solar nebula, a spinning, rotating disk of material. Think of it as a cosmic carousel, poised to give birth to planets, asteroids, and yes, even our dwarf planet, Pluto. This solar nebula was the cosmic womb, the birthplace where the raw materials of the universe gathered, fused, and began the intricate dance of planetary formation. From this spinning disk of material, the saga of Pluto's birth begins. As the solar nebula evolved, an amazing transformation took place. Picture a waltz of cosmic dust, with particles swirling in a gravitational dance around the young sun. These tiny dancers didn't stay small for long. As they moved to the rhythm of the cosmos, they collided with one another, sticking together in an act of cosmic accretion. Slowly but surely, these minuscule dust particles grew, becoming pebble-sized, then boulder-sized, and eventually they reached the size of small moons. These larger bodies, born from countless collisions, are what we call planetesimals. The ballet didn't stop there. Planetesimals, driven by gravity, continued to collide and merge, creating even larger bodies. It was a process of growth, driven by the constant merging and molding of these early solar system building blocks. These planetesimals, growing through countless collisions, were the building blocks of the future dwarf planet, Pluto. From tiny dust particles to a world of its own, Pluto's journey was just beginning. In the distant reaches of the solar system, a unique protoplanet began to take shape. This was a time of transformation and growth, a time when the raw materials of the solar nebula were coalescing into larger bodies. Among these bodies, one stood out. This was a protoplanet, a celestial body in its infancy, fated to become what we now know as Pluto. This protoplanet was born from countless collisions and accretions, growing in size as it swept up the surrounding dust and gas. Yet the story of Pluto's birth is not as straightforward as it might seem. Some theories suggest that Pluto may have actually formed closer to the Sun, in the warmer regions of the solar nebula. It may then have been nudged outward, migrating to its current location in the outer reaches of the solar system due to gravitational interactions with larger planets. This protoplanet, amidst the chaos of a young solar system, was the precursor to the Pluto we know today. Pluto's formation was not a peaceful process. It was marked by dramatic impacts and the birth of a moon. The dwarf planet's journey to its current form was a turbulent one, riddled with cosmic collisions that played a significant role in shaping its surface. These impacts, while violent, played a pivotal role in the creation of Pluto's most distinguishing feature, its moon, Charon. The birth of Charon is a fascinating tale of cosmic chaos. Imagine Pluto, in its early days, hurtling through the cold, dark expanses of space. Suddenly, a massive object, perhaps another protoplanet, collides with it. The impact is so colossal that it sends a shower of debris into space. This debris, a mix of rock and ice, doesn't just float away into the void. Instead, it orbits around Pluto, slowly coalescing over millions of years under the influence of gravity to form what we now know as Charon. But the story doesn't end there. Pluto and Charon share a bond that is truly unique in our solar system. Due to their close proximity and gravitational interactions, they've fallen into what's called a synchronous rotation. This means that they always present the same face to each other, just like how we only ever see one side of our moon from Earth. It's a cosmic dance that's been going on for billions of years, a testament to the enduring influence of gravity. In the grand scheme of the solar system, Pluto and Charon are relatively small players, yet their formation and evolution provide us with valuable insights into the processes that have shaped the celestial landscape we observe today. They remind us that even in the cold, distant reaches of the solar system, complex dynamics are at play, shaping and reshaping worlds in a never-ending cosmic ballet. So from these tumultuous beginnings, Pluto and its moon Charon emerged, forever locked in their unique dance. But why is Pluto a dwarf planet and not a full-fledged planet, you may ask? Well, let's dive into the factors that led to this classification. Firstly, it's a matter of size. Pluto is considerably smaller than any of the other planets in our solar system. Its diameter is roughly 2/3 the width of our moon, and it's only about 1/6 the mass. This diminutive size is one of the key reasons it was reclassified as a dwarf planet back in 2006. Secondly, it's about orbital characteristics. To be classified as a planet, a celestial body needs to orbit the sun and be spherical in shape, yes, but it also needs to have cleared its neighborhood of other debris. This means it needs to be the gravitational boss of its orbit, but Pluto's neighborhood, the Kuiper Belt, is far from cleared. It's packed with other icy bodies, making Pluto more of a local resident than a dominating force. Speaking of the Kuiper Belt, this is the third factor in Pluto's dwarf planet status. The Kuiper Belt is a vast region beyond Neptune, teeming with small icy bodies. It's like the solar system's frozen backyard, full of leftovers from its formation. Pluto's location in this cosmic belt further distinguishes it from the 8 recognized planets. But don't let the term dwarf planet fool you into thinking Pluto is any less significant. The Kuiper Belt, and its population of small icy bodies, holds vital clues about the early solar system. Each icy body is like a time capsule, preserving the raw materials from the solar system's birth. And Pluto, as the largest known resident, is an invaluable source of information. And so, in the outermost regions of our solar system, amidst a field of icy bodies, sits Pluto, a testament to the complex and fascinating processes that gave birth to our solar system. In the grand narrative of our solar system, Pluto plays a captivating role. From its humble beginnings in the solar nebula, Pluto's journey to becoming a dwarf planet in the Kuiper Belt is a fascinating tale of collisions and gravitational interactions. Its formation is an integral part of the larger story of our solar system's birth and evolution. The ongoing exploration of Pluto not only unravels its own mysteries but also provides valuable insights into our early cosmic history. As we continue to explore and understand Pluto, we unravel more about our own origins in this vast cosmic theater.